The last couple of circle theorems that we're going to look at. First one, radius meeting the tangent to a circle. The tangent to a circle always meets the radius. Here's our radius at right angles. Okay? So we can get that down. This is the type of thing, like I said yesterday, I recommend making some cue cards up for. There is quite a few of them. And then tangents from an external point are equal in length. Okay, so I'm going to scroll down. So tangents from an external point, here's our external point P, are equal in length. So A to B is the same as C to B. Everybody got the first one okay? And then the last one, the perpendicular bisector of a chord passes through the center of a circle. So basically if we've got the diameter or the radius, and if it's intersecting a chord, it's going to cut the chord in half. Okay, that's what bisect means, cut into two equal pieces, and it's also going to intersect it at right angles. So if we've got a radius or diameter intersecting a chord, it does so at right angles and also cuts the chord in half. To begin, we can just quickly have a look on transom. This is the last one that we did, just showing that it doesn't matter where the chord is. If your line is the diameter and going through the center of the circle, it's always going to cut this chord directly in half and always at 90 degrees. Okay? Nice and straightforward. The other one that we did was this one. So again, we're looking at the points between the tangent and where the two tangents intersect. It's always going to be the same. And again, these things are not particularly very difficult, but it's just a case of putting them all together in one. And then the other one that we did was this one today. Straight line always meets the radius at 90 degrees. Okay? Right. We're going to have a go at these following questions. I will show you not these ones. Okay, now these are on page 500 and on page 501 of the standard textbook. Okay, but I've also put them up here for you to have a look at, and we can also look at any that you need to. Okay, so I recommend doing a sketch of these each time, and if you want me to go over any in class, we can do that. Just be careful with D here in particular, okay? Yes. Just to work through this first one. Up here is 41 because this angle is the same as this. This is the same segment. How do we work out B? You recognize this is the diameter. It's connected to two chords that meet at right angles. So if this is 90, this is 41. Add them together. Subtract from 180. And you get 29 degrees. Maybe I didn't do my 41. uh, 41 plus 90.
Minus 3 is 5. In your little...
It is 49. This is why you should use a calculator. You've got one in your exam. Make sure you use it.
Can we have a printed one? Because this is taking so long.
Okay, I'll print it. Right. You see? I'm not sure. We need to look at it. Let's do D first, okay? How do we do D? Right, so G is half of 130 because we got our arrow shape. So half of 130 is 65. How then do you work out somebody else? How do you work out H? Right, good with the quadrilateral rule. So what do you do then, Samara? What the G and H?
They're
Not the same.
No, sorry, they're supplementary.
Yeah.
Add to 180.
They add up to 180. So if G is 65, H is 115.
Yeah.
Okay, now do not make the mistake. This is a really common mistake. Just quickly watch of thinking that this one and this one have to add up to 180, okay? No, 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 no. It has to be the angles on the circumference that are opposite, okay? So please do not make that mistake.
Just the opposite end of the circumference.
Say again? All right, so looking at this one, looking at E, this is kind of just, if you haven't done it, that's fine. But for E, this is this one, okay? You've got the horizon, you've got the sun, and you have got your sail, okay? Alternate angle segment theorem. So this one is the same as this one. So K is the same as this one up here. And J is the same as this one. And we know, well, it's isosceles, so this one is the same as this one. So hopefully that'll help you to figure out what this is and what this is. Okay, you always have to look for these shapes, okay?